This is lesson number 1 of college algebra. This first lesson is going to be divided into two parts. The first part, we're going to discuss the real number system, and in the second part, we're going to review the basic properties of exponents. In this course, we're going to be working mostly with real numbers. We're also going to be using complex and imaginary numbers, but for the most part, 90% or more is going to be real numbers. So the real numbers are the ones we are most used to. All right, and there are very important, several important subsets of the real numbers that are also um, special and deserve a special mention. They are given special names, and they also have special symbols for them, and we're going to be using them as well. So the first subset is the set of positive integers, which is also known as the natural numbers. So the set of positive integers or the set of natural numbers is just numbers that you use to count, not including zero. So 1, 2, 3, 4, 5, 6, etc. And the special symbol for the natural numbers is n, which is easy to remember because it's n for natural. Oops, and there's a typo right there. That should say numbers. Numbers. Okay. The next set of numbers that is special are the non-negative integers. And what is a non-negative integer? Well, it's the same as the natural numbers, but you throw in the zero. So the non-negative integers are 0, 1, 2, 3, 4, etc. And the notation or the special symbol for the non-negative integers is just the same as for the natural numbers, and you use a little subscript, zero subscript. That means that we're is the same as that, but including the zero, starting from zero. Okay, then after that comes the set of integers. The integers are the same as the non-negative numbers, but now you throw in the negative counterparts. So now you include -1, -2, -3, -4, -5, etc. So um, is all the whole numbers that are positive, all the whole numbers that are negative, and also zero. Some people call the non-negative integers the whole numbers. That's another name that some other people give it. All right, then we also have the rational numbers. The rational numbers are just the numbers that can be expressed as a ratio. A ratio is another word for like a fraction. So these are the ones that can be written in the form m over n, where both the top and the bottom are integers. They could be positive or negative, but of course the bottom cannot be zero. So if the rational number is m over n, then the n cannot be zero. And the special symbol is q. Q for quotient, which is another word for fraction. So q for quotient. This is like the set of quotients. All right, so those are the rational numbers. Again, the integers are, the special symbol for integers is z, and that's because of the word for number in German starts with Z, Zahlen, or something like that. All right, then after that comes the irrational numbers, and the irrational numbers, um, we're not going to be talking too much about those, but those are just the real numbers that are not rational, and the special symbol is I for irrational. And then the real numbers is just a set of all of them, is the set of rational numbers and irrational numbers. All right. And the special symbol for the set of real numbers is R. It's like an R, like that. All right. And if you're writing these symbols by hand, I mean, it's not the symbol for real numbers is not just a plain old R. Is actually like an R that has two sticks on the left. So R, and then for Q, rational numbers like that. For Z, the integers, and the natural numbers. Okay. Later on, when we talk about the complex numbers, the symbol for the complex numbers is C, C for complex. All right, so that's how you draw those symbols. Now, a quick reminder here that the rational numbers not only are the ones that can be written as a fraction m over n, where both the top and the bottom are integers, the bottom not zero, but there's another way of uh, defining rational numbers. It's like a characterization. And a rational number are going to be just those real numbers for which the decimal representation is either terminating, meaning it stops, or it doesn't stop but repeats. So like um, this number here, 3.2165, because it stops is a rational number. So that means you could represent it as a fraction if you wanted to. There's a way of doing that. Your calculator can do that for you. And then this one, 2.3333 forever, is also rational. And if you remember, 0.333 in forever is a third. So that part can be expressed as a fraction. So all the real numbers that either stop or have a repeating decimal part are rational numbers. And then all those for which you cannot, for which for whose the all those for which the decimal representation does not stop or repeat are not rational, meaning they're irrational. And examples, very famous examples, are pi. The decimal representation for pi is 3.14159, blah, 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 and that never, ever, ever stops or ever, ever repeats. So that's an example of a non-rational or irrational number. And then another famous one are square roots that are not whole numbers. So, for example, square root of 2 is not a whole number. You get a decimal. That also never stops and never repeats. Now, let's go over the basic properties of the real numbers, properties that we're going to be using over and over. Here's the basic properties. You have the commutative property of addition, meaning if you add two things, the order in which you add two numbers does not matter. A plus B is the same as B plus A. So like 3 plus 5 is the same as 5 plus 3. Does the same thing. That's called the commutative property. 5 plus 3 is the same as 3 plus 5. All right. Then you also have the commutative property for multiplication. So it's the same thing as this one, but instead of with a sum, with a multiplication. 5 times 3 is the same as 3 times 5. And that holds for any number. So using variables, you can say A times B equals B times A. Again, that's commutativity. The order there does not matter. The associative property of addition means that if everything is being added together, then you can move parentheses around. The order does not matter. So this says if I have three numbers that I'm adding together, A plus B plus C, then if I add the last two first and then add A, that's exactly the same thing as if I add the first two first and then add the third one. So the order in which you add things, if everything is being added together, the order in which you add things does not matter. You can move parentheses around, regroup things. Same thing for multiplication. If everything is being multiplied together, you can move parentheses around. You can multiply the last two first and then multiply that by the first one. Or you can multiply the first two first and then multiply by the third. That's called the associativity for both addition and multiplication. The distributive property, now that's the one that allows you to distribute. So if you have multiplication in a sum and you're multiplying something like that, so A times B plus C, you can distribute this, and the way you do that is A times B and then A times C. So this is going to be equal to A times B plus A times C. And of course, because the multiplication is commutative, the order does not matter. It would be the same thing if I had the A on this side. So you can distribute here A times B, A times C, A times B, A times C. That's the distributive property. Then you have the identity property of addition. If you add 0, it doesn't do anything. That's obvious. If you multiply by 1, that doesn't do anything either. The inverse property of addition, if you have a real number and you have a corresponding negative number, so like 5 plus negative 5, that gives you 0. So like 5 plus negative 5, that's 0. And if you multiply a number by the reciprocal, you get 1. Of course, the number cannot be 0 because you cannot divide by 0. And finally, so note that in all of these, there was no subtraction whatsoever. It was all multiplication and addition, and this one that is a little bit of a, that's a reciprocal. Well, you can define subtraction and division as follows. Any subtraction can be converted to an addition by just changing the sign of the second number. So you can change that minus to a plus negative. So A minus B is A plus negative B. Or, for example, 5 minus 3 is 5 plus negative 3. That's exactly the same thing. Okay? And then any division can be converted to a multiplication. Multiplication by the reciprocal. 5 divided by 3 is the same as 5 times 1 over 3. And then you multiply across. 5 is like 5 over 1. And then you multiply across. 5 times 1 is 5. 1 times 3 is 3. So you will get that 5/3. Okay, so any division can be converted to a multiplication. Now, lastly, we can talk about the order that real numbers have. All the real numbers can be arranged on a line. You can imagine them, all of them being on a line, on the so-called real line. And you can give them a sign. All the positive numbers are going to be to the right. All the negative numbers are going to be, all the positive numbers are going to be to the right of 0. And then all the negative numbers are going to be to the left of 0. And 0 is the only number that is neither positive or negative. 0 is like the point of reference. To the right of 0 means positive. To the left of 0 means negative. And there's no sign for 0. Okay, 0 is the origin where you start. Okay, so and as you move to the right, you become bigger. As you move to the left, you become smaller. So if you look at that line, because -4 is to the left of -3, that means that -4 is smaller. So move, if the number is to the left, it is smaller. If the number is to the right, it is bigger. So -3 is bigger than -4, or you can say -4 is smaller than -3. So as you move to the right, you become larger. As you move to the left, you always become smaller. And finally, the symbols, the famous symbols of inequality. Bigger, that means bigger than 0 or positive, less than 0 or negative, greater than or equal than 0 or non-negative, less than or equal than 0 or non-positive. I usually will say greater than or equal than 0 instead of non-negative, or less than or equal than 0 instead of non-positive, but those are that's what those words mean.